All right, today we're learning about atomic energy levels. First, I'm going to tell you about Joseph Fraunhofer, born in 1787. At age 11, both of his parents are dead. He was given to the royal mirror maker, Philip Anton Weichelsberger, who refused to let him go to school and forced him to work in the workshop all day and do chores all night. Um, but then in 1801, Joseph got his big break. Weichelberger's house collapsed on Joseph, with Joseph trapped inside. But Joseph was rescued by Maximilian Joseph, who was the future king of Bavaria. And Maximilian took an interest in his subjects, which was highly unusual for the time. And because of this, because the house collapsed and he was rescued, Joseph, he found an aperture into a different universe. He discovered a secret code written in black vertical lines, which unlocked the key to the cosmos. All right, the Bohr model of the atom. The atom has a small, positively charged center. That's the nucleus. That's where the protons and neutrons go. The electrons orbit the nucleus in discrete orbits. Each orbit corresponds to an energy level, and electrons can be found exactly at these orbits or energy levels and not in between. So we can have an electron here, you can have an electron here, but you can't have an electron in between these. It has to be in those orbits. All right, these are the electron energy levels. Um, these Bohr model orbits correspond to the energy level. So this is the closest orbit, this is the next closest orbit, etc. Electrons can exist at these energy levels, can be here or here, but not in between. Note, the energy levels they're not in joules, they're in electron volts. Note, the lowest energy level is the ground state, and the highest is ionization, which is to say when an electron leaves, something becomes an ion. So what does this have to do with our friend Joseph Fraunhofer? Electrons can only exist in certain orbits. That's the Bohr model. Therefore, electrons can only exist at certain energy levels. Therefore, atoms can only give off or take in certain amounts of energy. And since that certain energy amounts relates to frequency by the E photon equals HF, so atoms can only give off or take in certain frequencies. Therefore, atoms can only give off or take in certain colors. Okay, so the fact that we have these orbits means that atoms have distinct colors associated with them. So what did Fraunhofer see when Fraunhofer sent white light through a prism, just like Newton and Herschel before him? He discovered a pattern of vertical lines. These were spectral lines. Okay, spectral lines can tell you what something is made of. So we can see dark lines on a bright background is an absorption spectrum, or bright lines on a background give you an emission spectrum. So this is what the emission spectrum is, what an atom is giving off. The absorption is what it's absorbing. So what's the big deal? Spectral lines tell you what something is made of just by looking at it. So we can look at objects in space that are billions of miles away and tell what they're made of. It turns out that distant stars, planets, and galaxies are made of the same stuff as our planet. We can look at something that's a billion miles away, a trillion miles away, and see that it's made of the same stuff that you're made of and I'm made of. So what does our galaxy smell like? I know you guys were all itching to ask that question. It turns out the center of our galaxy smells like raspberries and tastes like rum. Basically, we can tell this because we can look at the center of the galaxy and see, based on the colors that we see, what elements make it up. And it's, yeah, it smells like raspberries and tastes like rum.